All right. Today we're going to talk about solving inequalities. An inequality is definitely something that's not equal to. All right. An inequality is when we're talking about something that's not equal to. Notice that when we have something that's equal to, like x equals -2, it's a point on the line. This is actually not the correct point, but it's a point on the line, particularly it's right here, right? But if we have something that's an inequality, maybe we have x is greater than or equal to -2. So we have this dot because of the equal to part, so it's a dot on the line. But then that greater than is pointing to the right, so that's why we have this red line that points to the right and continues with an arrow. That shows continuation. Or if we have x is less than or equal to -2, right? Notice how that sign is pointing to the left, right? So that means less than or equal to. Then we have the point at -2 and then the arrow that points to the left to represent this inequality. All right, but it's not always equal to, therefore we don't have a dot or a point on the line. Maybe it's just strictly x is greater than -2. Then we have an open circle here at -2, and then we shade to the right to represent our greater than. Or if we have x is less than -2, then we have this open circle at -2, and then we shade to the left. All right, so when we say open interval, right, an open interval and a closed interval, we might see just regular parentheses when we're talking about an open interval. All right, so that's when we're dealing with like less than or greater than. All right, when we have a closed interval, this is when we're dealing with the whole less than or equal to, right? That's when we have closed interval. It says, to know which direction to shade a graph, always write the inequality with the variable on the left side. So for example, if we have 6 is greater than x, we might want to flip that and write x is less than 6. Notice how this arrow is pointing to the left, right? So that means it's less than. All right, and it shows us which way to shade, which is to the left. All right, now that we've gone through the whole inequalities, the different types of inequalities, let's talk about a little bit further an inequality. All right, an inequality is a statement that compares two expressions that are not strictly equal by using one of the following inequality signs. All right, we have less than or equal to, greater than or equal to, and not equal to. So notice when you're pointing to the left, right, if we're looking at a number line, I like to use this because it kind of helps visualize some things. All right, so that's 1, 2, 3, -1, -2, -3, right? And so when we're pointing to the left, right, notice everything's going down, so that's less than. All right, and then less than or equal to, we already said, is when it's equal to the number and less than, right? And then we have greater than or equal to. We're pointing to the right. Not equal to is just an equal sign with a slash through it. All right, commit these things to memory. So really, we solve an inequality just as we would an equation, all right? But there's a little variation, and we'll talk about it. All right, so hopefully these look familiar to you. Step 1, step 2, step 3, step 4, all right? And then step 5. But here's the note. When you multiply or divide the variable by a negative number, you flip the inequality sign, right? You flip the inequality sign. So basically, when you get to this last step here, all right, that's going to determine whether you flip the inequality sign. All right. And let's look at an example. Let's say, for instance, we have right here 2b plus 5b is greater than or equal to 21. All right, and we're going to solve it just as we would an equation, right? So we have to ask ourselves, hey, does this have a parenthesis, right? The answer is no. Does it have like terms? If so, combine those like terms. Well, we see right here 2b plus 5b, right? We see that 2b plus 5b. So we combine those, right, to get 7b is greater than or equal to 21. All right. And then we go through the next steps. All right. Are there variables on both sides? Well, no, there's only a variable on the left side. Are there constants on both sides? Well, no, there's only a constant here. All right, so we're skipping. And now we're down to step 5. Solve for the variable b by dividing or multiplying, all right, using inverse operations. So this is multiplication. The inverse is division. So we're going to divide each side by 7 so that we have b is greater than or equal to 3. All right, so we have b is greater than or equal to 3. And then what we're going to do, this is our answer or our solution, right? It's not that b is equal to 3. It's also greater than 3. So we're going to represent this on a number line. All right, if this is 0, right? And then we have 1, 2, 3, 4, 5, 6. I know it looks small. All right, -1, -2, -3, yada, yada. All right, the main thing is let's make sure we graph this correctly. So this is 3. All right, I've plotted 3. That's b equals 3. But it says it's also greater than. So therefore, I'm going to shade to the right, which is the direction in which this arrow is pointing. All right, and I've shaded. I'm done. All right, I'm done. There was no flipping involved because notice how here we divided by +7, not negative. All right, so let's go to the next example here. All right, we have -3 times x minus 2 is less than 12. All right. First question, is there parentheses, right? The answer is yes. So therefore, we're going to need to distribute to remove the parentheses. All right, and distributing is just multiplying. -3 times x, -3 times, and I always say -2, but realize that means plus negative right here, which is why it's -3 times -2. So we have -3x plus 6 is less than 12. All right, we've gotten rid of the parentheses. All right, are there any like terms, right? Any like terms? Well, none over here, none over here. All right. So, next question, are there variables on both sides, right? Are there variables on both sides? Well, there's a variable here, variable term here, not here, right? So therefore, the answer is no here. Are there constants on both sides? Well, there is a constant here and there is a constant here. So the answer is yes here. So we need to move one of the constants to the other side by adding or subtracting. So it's the inverse, right? So here, the inverse, this is plus 6, but the inverse is -6. So we subtract 6 in order to move the constants together. All right. We bring down our -3x. +6, -6 cancels. And that's less than 12 minus 6 is 6. There we go. -3x is less than 6. Now I'm going to move this up here so I can have a little more space. All right. And then the next step says solve for the variable by dividing or multiplying. So use the inverse operations. Well, here, -3x is -3 times x. The inverse operation is division. So I'm going to divide each side by -3. All right. So now we have x, and 6 divided by -3 is -2. All right. But listen now, we just divided by -3. So that means this less than symbol needs to change to a greater than symbol. All right. So that's the change. That's the thing that you might be like, okay, that's all you need to know. We switched this sign because we divided by a negative, and that's what this says here. All right. So now we plot our solution. Let's say this is 0 and this is 1, 2, 3. Let's say that this is -1, -2, and -3. All right. This says x is greater than -2. All right. So we're going to have an open circle at -2. And since it's greater than pointing to the right, we're going to be shading to the right. And there we go. All right. We have some more examples here. All right. That we can complete. So we have a plus 2 times a minus 5 is less than 320. All right. Now, we got to go through these steps. Is there parentheses? You got it. It is. So we're going to distribute. Bring this down. A plus 2 times a is 2a. Minus 2 times -5 is -10 or -10. And then less than 320. All right. Got rid of the parentheses. Now, are there like terms? Well, when we look at this here, on the left side, are there like terms? A and 2a are like terms. So we combine them. A plus 2a is 3a. So we have 3a minus 10 is less than 320. All right. Next step. Are there variables on each side? None right here to the right. So that's a no. All right. What about constants on both sides? That's a yes. So we need to move this constant over here. All right. So we're going to add 10. So that we have 3a, bring that down, cross that out, is less than 330. Divide each side by the 3. So this is 3a is less than 330. Divide by 3. Right? Because that's the final step, solve for the variable. Because we did not divide by a negative, so we keep this inequality symbol as it is. So a is less than 110. If we are to plot, we have a 0 here. I don't know. Let's say we got 110 here, 220 there, 330, right? We put an open circle right here at 110 because it's strictly less than. So we don't put a dot. We put an open circle since it's less than. And then we shade to the left. And now I want you guys to try this last one, and we'll review it in class.